Imagine standing in an open field when the sky turns green. The air becomes eerily still. Then you hear it, a sound like a freight train barreling toward you. You look up and see it. A massive funnel cloud descending from the heavens, spinning at impossible speeds, ripping apart everything in its path. Before we get started, check out the link in the description to download our ebook. What really happens inside a tornado? What would you see, feel, and experience if you could somehow survive stepping into one of nature's most violent phenomena? Today, we're going inside the vortex to understand the terrifying physics of tornadoes and why they remain one of the most destructive forces on our planet. Tornadoes have fascinated and terrified humanity for centuries. They appear suddenly, strike with devastating precision, and vanish just as quickly. They've leveled entire towns, thrown cars hundreds of feet into the air, and driven pieces of straw through tree trunks like bullets. Yet, despite decades of research, tornadoes still hold secrets that scientists are racing to uncover. So buckle up, because we're about to explore the dark heart of nature's deadliest wind. Before we step inside, let's understand what we're dealing with. A tornado is a rapidly rotating column of air that extends from a thunderstorm cloud down to the ground. But not just any thunderstorm creates these monsters. You need very specific conditions. It starts with a supercell thunderstorm, the most severe type of storm system on Earth. These massive rotating thunderstorms form when warm, moist air near the ground collides with cool, dry air above it. Add in wind shear, where winds at different altitudes blow at different speeds and directions, and you create the perfect recipe for rotation. Inside the supercell, a rotating column of air called a mesocyclone begins to form. This is the engine of tornado formation. As the updraft intensifies, it stretches this rotating column vertically, making it spin faster and faster. Think of an ice skater pulling their arms in during a spin. The tighter the rotation, the faster it becomes. Then comes the moment of birth. A funnel cloud descends from the base of the storm. When it touches the ground, it officially becomes a tornado. And that's when the real terror begins. So what actually happens inside a tornado? Let's take an impossible journey into the funnel itself. The first thing you'd notice is the wind. But calling it wind doesn't do it justice. The rotating winds inside a powerful tornado can exceed 300 miles per hour. That's faster than a Formula One race car at top speed. These winds don't just blow, they scour. The intense rotation creates a sandblasting effect where debris becomes weaponized projectiles traveling at incredible velocities. But here's the part that shocked scientists when they first measured it. Inside the tornado, there's a dramatic pressure drop. As the tornado passes over a structure, the atmospheric pressure can plummet by 100 millibars in seconds. To put that in perspective, that's like being suddenly transported from sea level to 3,000 feet altitude in the blink of an eye. This pressure differential is catastrophic for buildings. The normal air pressure inside a house suddenly becomes much higher than the pressure outside in the tornado. The result? Buildings don't just blow apart, they explode outward from the inside. Windows burst, walls buckle, and roofs lift off like they're being pulled by invisible strings. The debris field inside a tornado is absolute chaos. Wood, metal, glass, cars, furniture, even entire sections of buildings spiral upward in the vortex. The centrifugal force pins this debris against the outer wall of the funnel, creating a deadly carousel hundreds of feet tall. Witnesses who've survived close encounters describe seeing recognizable objects, livestock, and vehicles, spinning past them in the maelstrom. And the sound? Survivors universally describe an overwhelming roar. It's not just wind noise. It's the combination of the violent rotation, debris colliding at high speeds, structures being torn apart, and the sheer power of air moving faster than most people will ever travel in their lives. Now, let's clear up some common misconceptions, because Hollywood and folklore have given us some wildly inaccurate ideas about tornadoes. First, the eye of the tornado. Unlike hurricanes, which have a calm eye at their center, tornadoes don't work the same way. Some very large tornadoes do have a relatively calmer core, but it's not peaceful. You're still inside a column of rapidly rising air with debris swirling all around you. There's no safe haven inside a tornado. Second, can you survive inside a car or by opening windows in your house? Absolutely not. Most people don't realize that hiding in a vehicle during a tornado is one of the worst decisions you can make. Cars become tumbling death traps. As for opening windows to equalize pressure, That's a myth that's gotten people killed. The pressure difference happens so rapidly that opening windows does nothing except waste precious seconds you should be using to get to shelter. Third, the idea that tornadoes can't cross rivers or mountains, completely false. Tornadoes go wherever the atmospheric conditions take them. They've crossed major rivers, climbed mountains, and even formed over water as waterspouts before coming ashore. So why are tornadoes so destructive? The answer lies in the brutal intersection of several physical forces working together. The rotational energy inside a tornado is staggering. A large tornado can have the energy equivalent of a small nuclear weapon. But unlike an explosion that releases energy in all directions, a tornado focuses its energy into a narrow, concentrated column. It's like comparing a hand grenade to a laser, both destructive, but in very different ways. The Coriolis effect, which influences large-scale weather systems, actually has minimal impact on tornadoes. They're too small. Instead, tornado rotation is driven by the conservation of angular momentum and the powerful updrafts of the parent thunderstorm. As air converges toward the center of the vortex and is accelerated upward, it spins faster and faster. Then there's the suction vortices. Large tornadoes often contain smaller satellite vortices that orbit the main funnel. These mini tornadoes within the tornado create concentrated zones of even more intense damage. This explains why you sometimes see one house completely obliterated while the one next door is barely touched. It's not luck or divine intervention. It's the path of those suction vortices. Let's talk about some of the most powerful tornadoes in recorded history, because understanding their impact makes the science real. The 1999 Bridge Creek Moore tornado in Oklahoma remains one of the most studied tornadoes ever. Doppler radar measured wind speeds inside this monster at 301 miles per hour, the highest wind speed ever recorded on Earth. The tornado carved a path of total destruction through suburban neighborhoods, and the damage patterns helped scientists understand just how extreme the forces inside these storms truly are. Then there's the 2011 Joplin tornado in Missouri. This EF5 tornado, the top rating on the enhanced Fujita scale, killed 161 people and caused nearly $3 billion in damage. It was so powerful that it threw a school bus over 100 yards and drove wood planks through concrete like nails. The Fujita scale, by the way, rates tornadoes based on the damage they cause. It ranges from EFO with winds of 65 to 85 miles per hour causing minor damage, all the way to EF5 with winds exceeding 200 miles per hour capable of sweeping well-built homes completely off their foundations and carrying them considerable distances before disintegrating them. Here's where it gets really interesting. How do you study something that's extremely rare, highly unpredictable, incredibly dangerous, and lasts only minutes? Enter the storm chasers. These aren't just adrenaline junkies with cameras. Many are trained meteorologists and researchers who deploy sophisticated equipment in the path of tornadoes. They use mobile Doppler radar units mounted on trucks to scan the internal structure of tornadoes from dangerously close range. This data has revolutionized our understanding of tornado dynamics. Scientists have also deployed hardened probes directly into tornado paths. These devices, built to withstand incredible winds and impacts, measure temperature, pressure, humidity, and wind speed from inside the tornado itself. Getting one of these probes in the right place at the right time is like winning the lottery. But when it works, the data is invaluable. From a distance, Doppler radar stations can detect the rotation signatures of tornadoes forming inside supercell storms. This technology has dramatically improved warning times, giving people precious extra minutes to seek shelter. But predicting exactly where and when a tornado will touch down remains enormously challenging. Now, let's zoom out. What about tornado patterns, climate change, and the future? Tornado Alley, the region of the central United States where tornadoes are most frequent, isn't a fixed location. Recent research suggests it may be shifting eastward, with states like Mississippi, Alabama, and Tennessee seeing increased tornado activity. This shift puts more people at risk because these areas have denser populations, more mobile homes, and tornadoes that often strike at night when people are sleeping. The relationship between climate change and tornadoes is complex. Here's the part that shocked scientists. While we might expect a warmer climate to produce more tornadoes, the data doesn't clearly support that. What we are seeing is a change in patterns, Tornado outbreaks, where multiple tornadoes form in a single day, may be becoming more clustered, with quieter periods followed by extremely active periods. The human impact extends beyond just the immediate destruction. Communities struck by major tornadoes face years of recovery. The psychological trauma, economic disruption, and social upheaval can persist for generations. As we step back from our journey inside the tornado, one thing becomes crystal clear. These phenomena represent the raw, untamed power of our atmosphere pushed to its absolute limits. They remind us that despite all our technology, all our understanding, nature still holds forces we can only begin to comprehend. Scientists estimate that we still don't fully understand many aspects of tornadogenesis. The process of tornado formation. Why do some supercells produce tornadoes while others don't? What triggers the exact moment of touchdown? How can we predict intensity more accurately? These questions drive ongoing research. What we do know is this: tornadoes are not monsters or acts of supernatural forces. They're the result of atmospheric physics playing out in the most extreme way possible. And the more we understand them, the better we can protect ourselves from their devastating power. So, which tornado fact surprised you most? Was it the wind speeds, the pressure drop, or maybe the physics behind the destruction? Drop your thoughts in the comments below, and if you found this deep dive into nature's deadliest force fascinating, smash that like button and subscribe for more science storytelling. Because the natural world is full of phenomena that challenge our understanding and inspire our curiosity. Until next time, stay curious, stay safe, and remember, if you ever hear that freight train sound and the sky turns green, don't try to observe. Just take shelter.